Hi guys, so we are starting today our neetcode and we have the next day, so it's day 8, so today it's day 9. So let's check. So we go to our neetcode map and we finalized yesterday with valid docu. So I finish it and actually it should work like this. So we have one loop over our metrics and we just create keys for each segment, for each cell. So for row, for cell, and also for box. For box, we just update I and C by 3, and we return false if it's already exist. So let's mark this as done and go to the next one. And let's start implementation. So we are given an unsorted array of integers num, and we have to return the length of the longest consecutive element sequence. You must write an algorithm that runs in linear time. Okay, so we are getting some unsorted array. So let's get it. So we are unsorted array. And we should return the length of longest consecutive element sequence. Okay, so we should return int, so it will be the length of longest consecutive elements. All right, so let's write some test cases. So we have 1, 2, then 4, 0, and -1. And in this case, we see that we have the longest consecutive is 1, 2. So the result should be 2. Then we have, for example, one for like here, right? So we can just copy this test case and check. So we have 1, then 2, 3, and 4. So we have 4. So we have unsorted array, and we should return the length of longest consecutive elements, right? So now let's think about constraints. So I would say that if we need some sorting here, then we probably need from 0 to 10 over 5. And we definitely have 10 over 5 here. And we have integers, so we don't actually need more constraints here. So let's think about approaches that we can use. So the first approach is simple. So we just sort our array and we just iterate and we check of the previous. If it's +1, we just have our current counter, and we have also maximum counter. And yeah, so sort with counter. This leads us to the time n log n with sort, and plus n because we need to iterate one more time to find the longest subsequent element. So space would be constant here, but actually it depends on the sorting algorithm. So what else? As we have quite big number of elements here, it means that we cannot store them in some array and do kind of how it's called. We cannot do count and sort here, so then we need to think about more optimal solution. What if we will create some kind of map, and in this map we will store an element, right? Some value, and here how much elements we have previously. So it will be prev count. And then we have also int max count. That would be 0. So how it should work? So let's go here, for example. So we have an array, and at the beginning we have like empty map. And also we have a 0 as max count. So we iterate our array. We take 100, so we put 100 here. And 1, because it's only one element, and because we don't have 99, so we put 1 here. Then we go to 4. So with 4 we don't have 3, So we put another. So yeah, so we have like this map. So we have another like 4 that equal to 1 because we doesn't have 3. Then we go to 200. With 200 again, we don't have 199, so we put 201. After this, we go to 1. So with 1, we don't have 0, so it will be also 1. Then with 3, it would be 1. And with 2, it would be 2. Yeah, so seems like it doesn't actually work because we need this. Yeah, so this approach actually doesn't work. So what else? What else we have here? Because with sorting, I think it should work, but let's take n is 10 over 5 multiplied by log n. So log n maximum is, yes, log n it's 10 over 5. Yeah, so we should just multiply by 5. So yeah, so we just 10 over 5 multiplied by 5. So actually should work. Like it should not go out time limits here. But let's think, maybe we have something more interesting. 4, 1, 3, 2. What if we, for example, will try to go, each time we will try to go down. So, for example, when we meet 1, or when we meet this 2, then we go down and we go up. So we go down. And we can, okay, and we can maybe have this map here. So, for example, on 100 we didn't meet anything, so we put 1. 4 we put 1, 200 we put 1, then 1 we put 1, 3 also 1, and then we have 2. So for 2 we check. Actually, for 3 we should update with for 3 because yeah, because for 3 we go down, 2 we doesn't have, and for 4 we have. So we have like 2, right? So we update 3 like for 2. Then we have 2. Then we update this 2 plus 2. It would be 4. Okay. 4. And what if we have, for example, 0? If we have 0, we go down, it's nothing. Then we go up, is 1. 4. Yeah, something strange. I think it doesn't work. Okay, what else? What else can be done here? What if we just, yeah, for each value, so we just put these values into the set. So we put 100, then 4, then 200, then 1, then 3. So we calculate for 3, we just go up and down, and we calculate 2, then we have 2, then we go again, like up and down, we calculate 4, and yeah, so we have kind of Yeah, kind of. But I think this one, it's even more, it's harder because it will be n squared here. Yeah, because for each value we try to go and calculate. So this one is n squared. So it's even a worse solution. So let's go with this first one. So what we do first, so we do array sort nums, then we have already sorted values. We have our result that is 0. We should return this result. After we return this result, we take I is equal to 1 into I is less than nums length, then I plus plus, and we check current and while nums, so while I is less than nums length and nums I minus 1 is equal to nums I, then we have like int tmp equal to 0, and here we increment our tmp and also increment I, and also should we update? I think no. I think we should not update, and then we have like result that will be mass maximum from result and tmp. So let's take this example. So what we have 0. First, what we do, we sort this array. So we have 1, 2, 3, 4, 100, 200. And then we start with this one. And we see that I is less than nums length, and nums I minus 1 is equal to i's so minus 1, so they should be actually equal, and if they equal, we increment I and increment this tmp. Let's say the tmp it will be 1. So we have 2, then we go to the next one because we increase. So we have 2 and 3, check, increment. So it will be 2, 3, then increment, and then 100. And when we see 100, so I think when we see 100, we go out, but I don't want to increment here, so let's do it like this. And so here, if I is less than nums length, I would decrement by 1. Let's run. Oh, no. Because, for example, if I have here 5, right? So if I have 5, then it just go down all the way. So I should increment this one. And here I just check if, and here else. So I just do like this, right? And here else. Else I think I don't need to do this. So I just do like this. Yep, and here, so I have 0, 1 and 1. I expect 2, 0, 1 and 2, so I should actually omit duplicates. I should omit duplicates. Yeah, so we can do it like first omit duplicates, like set, then we sort this set. Yeah, so it's good that we didn't ask about duplicates here. And that's why it's actually a medium question, I believe. So let's do like this. So we not only equal yeah, so and this one equal to this one, but here we just need to skip these values. We just need to skip these values, yes, and increment only TMP if we have this thing. Yes, and this one should be here. Okay, and that's submit. Okay, so when we have only one element, right? So let's start result with one. And here we can just do a check if nums length equal to 0. We just return 0. Okay, so we're done. We have 99% of our our submissions. So let's check what is better. Okay, so we have hash set. Okay, so we first add to the hash set, and then we iterate over our set. The if set contains yeah, I think we discussed this thing. So for example, we can just put we can put everything as a hash set. And maybe we can do like visited elements. So we put all our elements in the hash set, and then we have like a map of elements where we try to go only up. And I think, yeah, I think this one should work. So yeah, I think it's very good. So let's check submissions. Do I have submissions? Yeah, so I have yes. So I have visited and vals, right? So first I add two vals, and then if visit I continue, yes. Yes, yes, yes. So this one, yeah, it's more, I think it's more faster. But why it's not done? Yeah, so I think, yeah, the hash set probably would be better here. But sort algorithm also works. With hash set, it's yeah, so we solved this question, but it's not optimal. But I think it's all for today. So let's check the next task. I think the next task would be may become more complex. So let's go to the next one tomorrow. Thank you.